In this video, we'll learn what the chain rule is. So the chain rule is it tells us how to find the derivative of a composite function. So for those of you who don't know what a composite function is, a composite function is something f with this open bracket g. Now this is different from f dot g. This means multiply. If you see an open circle, that means the two functions f and g are composites. So let's say fx was x squared and gx was 2x plus 1. So the composite function f and g means that we substitute gx into fx. So we do f of gx. And so we get 2x plus 1 squared. So these are types of examples of composite functions. More complex examples would be like 2x plus 7 plus 2x squared to the power of, let's say, 4. That would be another composite function. Now, we previously learned that the derivative of a function is dy on dx. Okay, and this is pretty simple. Using the rule for differentiation. So if we had x to the power of a and x to the power of a, then the derivative would be a and x to the power of a minus 1. So if we were finding the derivative of say 2x squared plus x, we would move that down here, so that would be 4x plus 1. Okay, so that will be the derivative of 2x squared plus x. Now, what if we had to find the derivative of a function like y equals 3x plus 4 to the power of 20. Now, it's really inefficient to expand the brackets because it's to the power of 20. Even if you're using Pascal's triangle, that would take ages, and that's where the chain rule comes in. Okay. So we had y equals 3x plus 4, I think, power of 20. And we're trying to find the derivative, dy on dx. dy on dx. So what we have to do is we have to use another variable. Let's say u. So we have the variable u, and u is equal to 3x plus 4. That means the original function now becomes y is equal to u to the power of 20. So we get these two different functions here. And what you notice here is that these two functions are composite functions. They can be linked to give this final function. So if we call this fx and this fu, then the let's call it gu. Then that composite function would be g of fx. Okay. So if we wanted to find the derivative of this function here, u equals 3x plus 4. Now that would be du on dx. So du dx is equal to use the chain rule, so we get 3. Now we have to find the derivative of y equals u to the power of 20. So that would be dy on du, which would be 20 u to the power of 19. Now what you notice here is that if you multiply du over dx and dy on du, is that we get this, du on dx times dy on du. And the du's cancel out, and we get dy on dx, which is the what's it called? The derivative of the original function, y equals 3x plus 4 to the power of 20. So let's do it. du on dx is 3, and dy on du is 20 u to the power of 19. So the derivative dy dx is equal to 60 u to the power of 19. So that's basically the chain rule. So what the chain rule does is that it gets the derivative of the outside function and times it to the derivative of the inside function. Okay, let's try another example. Let's say we had y is equal to 2x plus 2x squared plus 2x, and that to the power of 14. So first we need to let u equal to 2x squared plus 2x. Oh wait, in our previous example we had like something like 60u19, then u was 3x plus 4, I think. You need to substitute this 3x plus 4 back into the function. So we get 60 3x plus 4 to the power of 19. And that would be the derivative of the original function. Don't forget to resubstitute u into your final derivative. Okay, that's really important. Now back to this example. We let u equal to 2x squared plus 2x. So the function becomes y equals u to the power of 14. Find the derivative of this. The u equals 2x squared plus 2x. So du on dx is equal to 4x plus 2. Okay, and the derivative of y equals u to the power of 14 is 14u to the power of 13. And we multiply these two together. So du on dx times dy du is equal to dy dx, which is 4x plus 2 times 14u 13. So we get 14 times 4x plus 2. And now we have to resubstitute the value of u into u to the power of 13. So we get 2x squared plus 2x to the power of 13. And that would be the derivative function of y equals 2x squared plus 2x to the power of 14. Now we'll try the chain rule with rational powers. Okay. So let's say we had y equals 2x plus 2 to the power of 2 on 3. So it's the same step. Let u equal to 2x plus 2. So our function would be y equals u to the power of 2 on 3. And we find the derivative dx, dy on dx, which is 2. Oh no, sorry, that should be du on dx. It would be dy on du, which is 2 on 3. Now we need to do 2 on 3 minus 1, so it becomes negative 1 on 3. So we multiply these two values together, so we get 4 on 3 u to the power of negative 1/3. So 4 on 3 times 1 over u to the power of 1/3, and we get 4 over 4 times, now as u, our u is 2x plus 2 and 1/3, correct? So now that's 3. Okay, so the derivative function would be 4 over 3 times the cube root times the cube root of 2x plus 2. That would be the derivative function for y equals 2x plus 2 to the power of 2 on 3. Let's try another example. What if we had x to the power of 5th minus 2x to the power of negative 3? Now, what we have to do here is recognize that this is a negative, so it's minus. When it's a minus or a plus, we would just find the derivative of these two functions and just add or subtract them. Okay, that's the easiest way. So if we find the derivative of x to the power of 1/5, that will be 5th x to the power of negative 4 and 5. That will be negative minus 2 times negative 3x to the power of negative 4. Just simplify that a little bit. It'll be 1/5 times 1 on x to the power of 4 on 5 minus plus 6 times 1 on x to the power of 4. I skipped a few steps there, but hopefully you can see what I did. And then we get 1 on 5. Okay, now that's the 5th root of x to the power of 4 plus 6 on x to the power of 4. Now, in an exam, you may be able to get away, no, not in an exam. Sometimes you'll be able to get away with this here and just simplify that straight to 5th x to the power of negative 4 and 5 plus 6x to the power of negative 4. But usually, in like exams, you would want to change that negative indice into a positive indice. So by putting it in the denominator. Okay, and we'll finish the video with one more example. Let's say we had 3x plus 2 to the power of negative 3. This one's a very easy question. So we let u equal to 3x plus 2. So our, that should be y. So our function becomes y equals u to the power of negative 3. The derivative, du dy, du dx, is 3 for u equals 3x plus 2. And the derivative for y equals u to the power of negative 3 should be equal to negative 3 u to the power of negative 4. Multiply these two together and we get negative 9 u to the power of negative 4. Resubstitute u equals 3x plus 2. We get negative 9 3x plus 2 to the power of negative 4. And that is the derivative. So y dash equals negative 9 bracket 3x plus 2 to the power of negative 4. And that's the derivative of our original function. If we want to change the negative indice to a positive, we can just put the 3x plus 2 in the denominator and that to the power of 4. So that was basically the chain rule. Just a quick summary of this video is that the chain rule gets a composite function and allows you to find the derivative by taking the derivative of the outside and the inside and multiplying them together. So dy on dx is equal to du dx times dy on du.